You came here wanting to learn what in the hell caused the Chilcotin landslide. And I'm going to list for you a dozen cues that points to the cause. I'm not going to tell you what the cause is. Dozen cues. You go home and do your homework. Number one, this is the first cue. Landslides are frequent over the landscape in the Caribou. Frequent. They're all over the places. Frequent, and I've shown you. Downtown Quesnel, downtown, right? Frequent. And the emphasis is on, Lori, the emphasis is on the word frequent, because that frequency can only come out over the probabilistic framework. And if landslide is a regional problem, mon ami, the cause can only be regional cause. So you need to find out the regional cause. And the loss of the forest cover is a regional phenomena. All right, moving on. 2, at the same location, and the city of Quesnel and the city of Williams and the regional Caribou district have been monitoring continuously for the last 20 years. The same location, they want to know how much it's moving. They have been seeing this movement appearing again and again and again at the same location every year. Every year, the same location is moving. So that the same location landslides are repetitive, one freshet after the other. Therefore, frequent over time. And again, the frequency dimension. 3, the frequency of landslides have accentuated since the mid-Doug. This is yours. Frequency of landslides have accentuated since the mid to late 90s. You need to ask yourself, what happened in the 90s? Many have blamed the landslides. Many have blamed the landslides to the fact that the Caribou region is vulnerable to landslides. And the city of Quesnel and the city of Williams Lake are actually developed and built on an ancient landslide. Even if that's the case, what the hell awakened the ancient landslide? And the late 90s was a trigger. There's something that have happened in the 90s that have suddenly triggered, not only triggered, have awakened the dragon, the ancient landslides, but also it has accentuated, increased in frequency and magnitude in the last 20 years, after the 90s. And you know from that time-lapse video that I showed, we lost most of our cover over the last 30 years. Bon. Listen to this. Landslides are more common and more dramatic near the banks of major rivers, the Quesnel, the Chilcotin, and the Fraser. Why? Because the groundwater table elevation, which is the regional response of the landscape to snow and rain, and the way the moisture has been affected by disturbance of the land, that groundwater table near the banks is the response of the entire landscape below the ground, upstream of it, all the way to the headwater, and sometimes even from neighboring watershed, because the groundwater table doesn't see the surface water boundary of the watershed defined based on the topography. There could be watershed leaking below the ground and you're not aware of it. Talk about cumulative effect. If the landslides are triggered by higher and more frequent groundwater table elevation, the true cause cannot be local. You cannot blame a particular landslide on the bank to the last cut block, because the soil have been weakened over time with the huge amount of logging that has happened over the last 30 years in the entire landscape, and sometimes even outside the Chilcotin. Because what goes below the surface in terms of drainage, right? It's not the It's not the topography that defines the size of the drainage for a groundwater table. It's the bedrock topography. If the landslides are triggered by higher and more frequent groundwater table elevation, the true cause cannot be local, it's regional and cumulative over landscape and over time. Over landscape because there is logging and changes over time, but over time because every freshet, that groundwater is suddenly higher as a result of perhaps a higher precipitation, but perhaps loss of forest cover. And every time that groundwater moves up and stays higher for a bit longer, the soil is going to lose some of its strength over time. And that has been demonstrated using the monitors in the downtown of Quesnel and downtown of Williams Lake for the last 20 years. And this is why integrating the time dimension, therefore all the previous freshets or rain event with the landscape, because you've got things changing over the landscape over time as a result of disturbances in general. The heightened risk of landslides appears to be occurring in concert with the heightened risk of flooding. Because if you don't have trees to evapotranspirate from the ground, you have more runoff in the river for sure. And Baker Creek, which is a 1,700 square kilometer watershed, the outlet of which is in Quesnel, have been in the news, have been heavily logged and salvage logged since the late 90s. It has been in the news for floods every year, every other year. Therefore, you've got a double whammy in here. You lose the forest cover. And again, I don't care how you lose it. You've got not only higher floods, but also higher flood risk, landslide risk. And I'm hoping in a soon to come presentation, I will actually bring new research that shows that the loss of the forest cover and replanting the coniferous in the cut block exacerbate droughts. But that's another story for another day. The loss of the forest cover, whether on coast or in the interior, our new research have now shown that replanting the trees and younger trees consume way more groundwater than the older trees that were logged, and that actually exacerbate the droughts. This has been demonstrated by colleagues, not from my lab, but even at OSU for the coastal environment. But the logging practices could exacerbate the droughts because of forest roads. Because the forest road network intercepts subsurface flow, changing it into surface runoff into the ditches, into the culvert, and the culvert into the gullies, and out to the ocean quickly, especially for coastal watersheds. Do you know what other mechanisms associated with logging practice that could potentially exacerbate the droughts? Is the melted drip in the snow transient environment on the coast. On the coast, this mid-elevation zone, where the snow falls in the form of wet snow, and the temperature hovers around 0, that wet snow is ready to melt. Intercepted by the canopy, the old canopy, is ready to melt. And when it melts, it falls in the form of melted drip, and it recharges the groundwater. And as long as the wet snow is falling, from mid-October all the way to end of March. And that melted drip over those 6 months is very valuable for making sure we've got enough low flows during all year round, especially for coastal streams that have fish in them. And I can assure to you that these intricacies can only be revealed by the right causal framework. 7, listen to this, because I have seen consulting reports that have blamed the landslides in the Caribou on precipitation, on climate change. When in fact, The wider literature in hydrology and climatology established that Western North America is receiving less precipitation over time and not more as a result of global warming, at least in the form of snow. That hints to potentially climate change increasing precipitation is ruled out. Most landslides happen in the spring. Guess what? Most of the landslides happen in the spring. Therefore, it's related to snow. And the snow plays a big role in the recharge of the groundwater table. And the recharge of groundwater table through the melt of the snow from the outlet all the way to the ridges raises the groundwater table and increases that water pressure on the soil. One year after the other, one freshet on the other until that soil is ready to go. But you cannot blame it when it goes to just the last freshet. No. That's a deterministic framework to cause-effect relation, and it's not defensible. 9. Lost forest cover in the caribou, and I said this before, used to relieve the ground from excess soil moisture via evapotranspiration at a minimum 50% of the total precip, at a minimum. This dry snow environment, where the mean annual precipitation, I don't know, it's low. In the caribou, it's low. What? 600? What? Huh? Anybody? Any guess? It's low. 50% of it would have lost if you had the old forest.